Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Visible Arrows 4 by MD88 Keys, or as I like to call them, Dr. Piano. Anyways, here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. We have counting circles, where a digit in a circle indicates the number of circles which contain that digit. So, for example, if this were, say, a 3, that means we would have to have 3 threes in total in the circles. So this would satisfy the counting circles rule because we have a 3 in the circle and there are 3 threes total in circles. That's an example of how counting circles work. We also have arrows, where digits in a circle also equals the sum of the digits on the attached arrow. So for example, if this were, say, a 3 and a 4, this would have to be a 7, because these two digits must add up to the digit in the circle. And again, remember that also counts as a counting circle, so it must satisfy both rules for these cells. And digits may repeat on an arrow, assuming normal Sudoku rules are followed also. So you could have something like, say, 1, 1, and 5, and then this would be 7. And this would be valid. Because 1, 1, and 5 add up to 7, and these do not see each other because they're not in the same row, column, or box. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's start by counting how many circles we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 circles. We are guaranteed one of them cannot be 9. There could potentially be up to 5 different ones, because 1 through 5 adds up to 15. But we are guaranteed only that there's only at least 2 unique digits. So there's 2 to 5 unique digits in the circles. So it could be 7 and 8 potentially. I think there has to be a high digit. Okay, so not necessarily, actually. You could have okay, you do. You have to have a high digit, so it cannot be the digits 1 through 5. The reason why you know that is this has a sum of 3 digits, 2 of which have to be unique from each other, 1 of which does not. Oh wait, that's not true. It could be 4 and 5. Is that possible, though? The answer to that is no. So the sum of these 2 digits is basically the sum of these 3 digits and these 3 digits, right? These 2 digits, if it were to be 4 and 5, it would have to add up to 9. But we have these 3 digits and these 3 digits summing up to the same digits, same sum as these 2 cells. These cells is at minimum 1, 2, and 3, which adds up to 6. These 2 cells are at minimum 1 and 2, which add up to 3. So, and this could be a 1. So that means in total, they must add up to 6 plus 3 plus 1, which means it's 10. So you have to have 1 low digit at least and 1 high digit. So actually, you don't even have to have a low digit. It could be 2 high digits or 2... Well, cannot be 2 Well, it could technically be two high digits. You have to guarantee have one high digit, which means it's 6 through 9, right? Um. Ugh. Oh, same here. Ah, these two digits must be the sum of 5 digits, which is at minimum 1 through 5. And since those two are the sum of digits that must be adding up to 1 through 5, well, guess what? Those are the only two digits in the circles. Because this is either, well, it has to be, cannot be 9 because there's no circle in column in row 9. That's the reason why we know 9 is not possible. This has to be a 7-8 pair, which must add up to 1, 2, 3, 4, 5 in box 9 here. This is guaranteed to be 1, so this cannot be 1 here. It's either 2, 5, 3, 4, or 2, 3, 5 here. That leaves this as a 6, 9 pair. Again, in the circles, they can only be 7 or 8. They all appear in row 1, row 2, row 3, row 5, row 6, row 7, row 8. So that means this must be an 8 here. Because there's 2 7s or 8s each in rows 1 through 3, 5 through 8. So this is the only 8 that could be more. So this is 8, which makes this 7, which makes this 8, which makes that 7, which makes that 8, which makes this 7. That makes this 8, which makes this 7, which makes that 8, which makes this 7, which makes that 8. This 8 eliminates 8 here, so it's 7, which makes that 8, which makes that 7, which makes that 8. 7 is the same as that digit there, so that's 7. We have 8 sevens. We know where the last 7 has to be. It has to be here. So this is 7 and 1 adding up to 8. We have 8 eights. We know where the last 8 has to be. It has to be here. So this is 8. 7 has to be here. And it could have... we know 9 can never appear on an arrow. So in box 1, where is the 9? It has to be here. Because everything else is on an arrow. Huh. Where is 9 then in box 3? Can't be here because of the 9 in the row. Can't be any of these because they're all on arrows, so this must be 9 here. Well, where is 9 in box 6 then? Can't be here because of a 9 in the column. It can't be on the arrow, so 9 has to be here, which makes this 6, which makes that 9. Okay, where is 9 in box 2? Can't be here because of 9 in the row. Can't be here because of 9 in the row. These are filled out, so this must be 9 here. Don't have any other real information for 9, so let's leave that for now. Okay. Remaining digits in column 7 are 1 through 5. Remaining digits in column 8 are 1 through 6. Remaining digits in column 9 are 1 through 6. So these two must be 1, 6, 2, 5, or 3, 4. These two cannot have a 1 because 1 and 7 would have to add up to 8. This can't be 4 either. This can't be 1 either, and this can't be 4 either because 2 digits adding up to 8 here. uh, let's see. Remaining digits in row 2. 1 through 6. This can't be 1 because can't be 1 or 4. This is 2, 3, 5, 6, adding up to 8. This cannot be 6, and this cannot be 6. What can this be? This could be at most 5 here, because it could be 1 and 2 here with 5 to add up to 8. This can be at most 4. 1 and 2 adding up with 4 to add up to 7. Okay. Remaining digits in row 3 are 1 through 6 again. This is 1 through 6. This can't be 6, because if this were 6, that would be 1 and 2 at minimum. That adds up to 9. This must be 1, 6, 2, 5, or 3, 4 here. Okay, so this adds up to 7 here. That means the remaining digits in these cells, in this box, shall I say, adds up to 7 times, or 21 minus 7. Because 1 through 6 adds up to 21, minus 7 is 14. So these arrows add up to 14. This is 1 at minimum here, 1 at minimum here, which adds up to exactly 16. So this must be a 1 here and a 1 here, which eliminates 1 in the rest of the rows. That means 1 has to be one of these digits here. This cannot be 6 anymore because that would force a 1 here. This 1 eliminates 1 here, and this can't be 1. So this cannot be 6 here. This is 1, 2, 5, or 3, 4, adding up to 8. Where is 1 in column 8? It can only be here. So this is 1, which eliminates 1 in the rest of the column, or box. This is 1, 2, 5, or 3, 4. This can't be 6, because if it were 6, where would the 1 be in this box? It cannot be here, because that would have to be 1 and 6, adding up to 7 here. This cannot be 2 and 5, adding up to 7, because that would eliminate all possibilities for this cell. This could be 1, 6, 2, 5, or 3, 4, adding up to 8 here. So this cannot be 2, 5. If this were 2, 5, that would eliminate all possibilities for this, these arrows here, right? Because it requires 2, 6, or 3, 5 here. So this cannot be 2, 5. This again is 1 through 6, adding up to 7. This cannot contain a 1 in any of its arrow. So that means it's at minimum 2, 3 here, and 2 here, which means it has to be that minimum, because that adds up to exactly 7. If you increase anything there, it would not work. So this has to be a 2, 3 pair. This is 2, which eliminates 2 here, which means this can't be 6. This can't be 2 either. This 2 eliminates 2 here, so this can't be 5. Where is the 2 in row? This 1 and 2 can't be 1 and 2 here, so this can't be 5 or 6. Remaining digits in row 9 are 2 through 5. This can't be 2 or 3 because of the 2, 3 pair in the box. This can't be 2 because of the 2 in the column. This could be 2. Where is a 2 in row 3 again? It has to be one of these 3 digits, so that means 2 cannot appear in the rest of box 3, because it has to be 2 in one of those digits. This can never have 5 here, because 1 can't be here, so it can't be 1 and 5, adding up to, with this digit. It could be 1, 4, 2, 1, 3, 3, or 1, 2, 4. So those are all possibilities. The remaining digits in column 4 are 4, 5, and 6. So this can't be 6 either. If this were 6, this would not be 2 here. You can't have 2 anywhere else in the box, and therefore this can't be 6. Which means where is the 6 in box 6? It has to be one of these two digits, which eliminates 6 here. So this can't be 2. So 2 has to be one of these two here. Okay. 6 in box 3 has to be one of those two. Okay, this digits adds up to 8, so it's either 2, 6, or 3, 5. Remaining digits in column 3 are 3 through 6. Okay. If this is 2 and 6, this would have to be a 3, 4, 3, 4 pair. So this could not be 2, 3, or 4. It would have to be 5, which would force this to be a 3, 4 there. If this is 3 and 5, where's a 2? 2 cannot be here. 2 would have to be here, which would force this to be 3, 5, which would force this to be 1, 6. So then this would be 4. So either way, this is 3 or 4 here. Interesting. Remaining digits in box 8, 4, 5, 6, and 9. Okay. Okay, let's look at pairs that add up to 7. This adds up to 7, and this adds up to 7. So we're going to mark this as blue, and this is green. That means the blue pair has to be in these digits there. The green, these cannot add up to 7. So this must add up to 7 with one of these. We don't know which. So this is definitely one that adds up to 7. Ah, so this can never be 6 then. If this were 6, where are both of these green cells? They would have to be these two cells, but they would add up to 8. So that's not possible. So this cannot be 6 here, which means where is the 6 in this box? It has to be here. So this is 6 and 2. This cannot be 2 here. Therefore, where is the 2 in column 7? It has to be here. So this green must be 2 and 5. So this is 5. This cannot be 5. This is a 1, 3, 4 triplet. That eliminates 2 and 5 in the rest of this box. This is 3 and 4. We have a 3, 4, 5 triplet in row 9, which eliminates 3, 4, 5 in the rest of the box, or row. So this has to be 2. This cannot be 2 and 2, then 5, because of that 2, 5 pair. This 6 eliminates 1 and 6 here, so this is a 3, 4 pair. This 3, 4 pair eliminates 3 and 4 here, because of 3, 4 in the rest of the 3, 4 pair in the column. So this is 2. This can't be 3, 4, or 2, because of the 2, 3, 4 in the column. So this is 1 and 6. This can't be 1, 2, 3, or 4, because of the 1, 2, 3, 4 quadruplet in the column. So this must be 6, which makes this a 1. This must be 2 and 5 added together to add up to 8. This can't be 3 or 4 because of a 3, 4 pair in the row. So this is 1, and it's not the blue. Therefore, this is the blue here. It's 3, 4 as a pair. This can't be 2. This is 3 and 3 at minimum. That adds up to 7, which is the exact amount we need. So this has to be 3 and 3, which makes this 4. This can't be 2, 3, 4, or 5. So this must be 6 and 2, adding up to 8. That eliminates 6 here. Where is the 6 in the rest of column 4? It has to be here. So this cannot be 6 here. This can't be 2 and 6. This is 3 and 5, which eliminates 3 and 5 in the rest of the box. So this can't be 3 and 4 as a pair, adding up to 7. This must be 6 and 1. That means this can't be 1, 3, or 5, so it's 4. That leaves this as a 2. So this can't be 2 and 6. This is 3 and 5. 3, 5 pair eliminates 3 and 5 in the rest of the row. This can't be 3. So this is 4, which makes this 3, which makes that 4. This can't be 4, 5, or 6, so this must be 3. This can't be 3, 5, or 6, so it's 4, which makes this 5, and it makes this 3 and 4. 5 cannot be any of these. This can't be 6 because of 6 in the column. 3 here eliminates 3 here, so it's 5 and 3. This 5 eliminates 5 here, so it's 4, which makes this a 5. Okay. Remaining digits. We have 3, 5, and 9 in box 7. This can't be 3 because of a 3 in the column. This 3 eliminates 3 here, so it's 5 and 3. This can only be 5 and 9, and it can't be 5 because of 5 in the row. So this is 9, which makes this 5. So neither of these are 5. This 5 eliminates 5 here, so it's 2 and 5. So this has to be 2 and 5. 2 eliminates 2 here, so it's 3 and 2. 3 eliminates 3 here, so it's 9 and 3. This 9 eliminates 9 here and here, so it's 4 and 6, which makes this 9. Remaining digits in column 6 are 1 and 4. This can't be 1 because of 1 in the row, so this is 4 and 1. Remaining digits in column 5 are 2 and 9. This can't be 2 because of 2 in the row, so this is 9 and 2. That leaves this digit as a 6 and this digit as a 5. And that's the solution. So, yep, fairly straightforward. Yeah, I like the logic behind it. Obviously, counting the circles is important, but also figuring out what these can add up to is also very important. And we use the arrows a lot to map to what they could with the digits in the circles too. So that was interesting. Very cool. Very nice solve. And I hope you enjoyed this solve. And I'll see you next time on Frank Puzzles. Take care.